Hi, everyone. Welcome to Always Coding. This is our weekly Hacky Hour. I'm Komal Devjani, a developer advocate with Always AI, and I'm joined today by Todd Gleed, our model training product manager. So welcome, Todd. And
Thanks, Komal.
thanks, Todd. And I'm also joined by Laila Milani. She's also on the developer advocacy and software engineering team. So welcome, Laila. And so Hacky Hour is kind of like our office hours. This is intended for our community of developers to join us, ask questions, anything related to computer vision or an application you're building, or simply share your feedback or what you're working on. This is intended to be an interactive session, so don't hesitate to raise your hand at any point. We'll get to you, unmute you, and you can ask your question, or you can also use the Q&A button at any time and ask your question there as well. So today's Hacky Hour is focused again on model training, and this is our holiday special, which is going to focus on how to identify a package at the doorstep. So inevitably, at some point during the holidays, we order some Amazon packages or something online. We take advantage of these holiday deals, and we'll see some outside of our door. So this is an opportunity for you to build something and automatically recognize when there is a package at your doorstep. So we're going to walk through how to go about training a model for that and then building an application for that as well. Before I give that stage to Todd to talk about that, I'm just going to show you how to get started and set up really quickly with Always AI. So let me share my screen and actually make sure that everyone can share their screens. So let's go and navigate onto alwaysai.co. And you want to go ahead and register for an account here if you haven't done so already. I obviously have, so I'm just going to navigate into my dashboard. And as you can see here, you can learn more about training a model. You can create a project and add in a model onto your project, run a sample project, the Hello World face detector, and see some of our most popular sample apps. So what I want to do, I've actually already created a project, so I'm just going to go ahead and show you how it will work. So this is the object detector Hacky Hour. I'm just going to quickly run a simple object detector. We are using the MobileNet SSD model. Before you can run your model, you need to make sure that you have downloaded the CLI for your specific operating system. I'm of course using a Mac, but if you're using Windows or Linux, you can just click this button. It should show it for your specific operating system. And now what I want to do is I've already actually opened it to my directory and we can run this quickly. Let's copy this first command and paste it into the terminal and hit enter. And I want to save this on my local computer. Next, I want to do AAI app install. And then we're going to do AAI app start. And looks like we're up, and we're just going to copy this link and paste it into an empty web browser. And as you can see, it can detect me, a person. It can detect my Monstera in the back. I've placed it like that on purpose, so you guys can take a look at that. And yeah, that's how you run a object detector. So with that out of the way, I'm going to hand it back over to Todd to show us how to train a model to detect a package at the doorstep.
Thanks, Komal. Hi, everyone. Back for some more model training Hacky Hour. What we're going to focus on today is the data collection part of training our model. So let me share my screen, and I've got just a couple slides to ground us here. And let's see. And we're going to try some stuff out with videos and things. I don't know how it's going to work out. Can you see my screen?
Yeah, we can see the slides.
Okay, good. So yeah, just to go an overview of what I'm going through today. So I'll talk a little bit about the project. That's what Komal just went over. Talk about prepping for data collection, which is defining the use case and scoping the model for the project that you want. Setup, kind of how I set up to collect the data, capturing the data, show you what I did to capture it, and then what I did to clean, analyze, and improve it. And I did a couple steps of that. I'll walk through what I did there, and then set up for next time with the application that we're going to build around this model. So at any time, if you have questions, comments, feel free to jump in. I wish this that I could be outdoors and show you the setup live and everything like that, but we'll see how this works. So just like Komal said, we want to identify a package on the doorstep. You know, we're going to try and do a little bit more than that. You know, maybe some theft protection or alerts once the package gets there, but we can talk about that a little later. And so the first thing we need to do is collect data. And if you're thinking of a project like this, you got to scope it. So this project is really focused on my front doorstep. That's where we set up the camera, and that's where I'm going to collect data, and it's going to be best suited for that. Thinking about this, when you're thinking of your own project and setting up data collection, there's just a couple questions that you can answer. Like, is it feasible? And I guess when I'm thinking of this is if you want to build like a space shuttle detector, you're not going to be able to go and collect your own data for that. Or if you're doing something that is pretty exotic with animals, you can collect data online, but you're not going to get as specific as you are if it's something closer to home to prove the concept. So just kind of make sure that you're able to acquire the data in some way before jumping off on a really extreme project. And then so once you've identified the project that you want to build the model for, what is a way where you can create a scene, bring in props, bring in locations that is going to be representative of the project in the wild. So in this case, props. I started saving boxes from Amazon, boxes that we got for food delivery or whatever it is, for a week or two beforehand, so that I'd have the props available to recreate this. For location, we kind of defined my front door, but if you're building this as a suite for home security, maybe you want to collect on your side door, your back patio as well. What locations are you going to collect on? Or if this is a more commercial product, you want to be more general and have more locations in mind and kind of vary those up. Lighting and time of day and weather kind of all go together in terms of the hues and the contrast and different things. You'll see in some of my data collection, it was at a time of day where there's streaks of light on the packages, because where the sun is, it's coming through the trees, and those shadows can really play with the object you're detecting. So kind of be cognizant of that, as well as nighttime. If you're away and you want to know if the package is still there at night, get examples of that as well. Let's see. So setup. So the equipment I use is just what I had around my house. I have a webcam that I use with a Raspberry Pi, a GoPro Hero 4 that I haven't used in a while, but I brought this out, and my phone. Tools. What I was mentioning with tools is I have this kind of Gorilla Grip thing that you can put the webcam on to set it up. I used a lot of tape, which I'll show you in the video, and I have this kind of GoPro selfie stick that I set up, and I'll show you to go. And so location, you can see I kind of propped it up on my screen door there, with the idea if I ever mounted something, I'd want to be above looking down. And then assistance, you'll see in the video where I'm controlling a lot of the stuff through my computer, and it's hard to control and put boxes for testing. So it'd be much better if we weren't in quarantine and we could do this as a team. But let me try and kind of show you how I set up on my doorstep, and I may need to just talk through this. I don't know if you can. This might be a funny video. Oh, and I did it vertically on my phone. but this is the kind of the day of, and I have my boxes set out there, and I have my setup, and I'll show you. Let me know if you can hear the video or if I need to kind of talk through it.
Yeah, we can't hear it. But
Okay.
you can, when you share screen, you can share sound as well. So if you try that, you might be able to like have that come through.
Sure. Share screen.
And then there's like a little button at the bottom that says share computer sound or share
Oh,
desktop
there it
sound.
is. Share computer sound. Optimize screen share for video clip. Should I do that too? Sure. But I mean, if it doesn't work, I know what I did, so I can talk over it too.
Yeah, I'm more interested to know how many packages did you have to order to train this model?
Yeah, you know, I kind of got them coming pretty regularly. But good thing is, right after I trained the model, I got 2 new packages. So that was some good fresh data that I knew it wasn't overtrained on.
Yeah,
So I
your
don't
validation
think,
data arrived.
yeah, I don't think it likes this. Quick, maybe if I do just QuickTime Player, it kind of froze.
Yeah, it looks like it's asking you to enter your password to allow Zoom
Oh,
to share.
sorry, I'm looking at the wrong one. Thank you. Let me know now.
Okay, I'm going to quickly document my dataset creation process here. So I'm doing a parcel detector. I've got my boxes staged here. All boxes. Got my laptop ready to run Always AI through my Raspberry Pi that's plugged into my external generator. Expertly masking tape to the door, running up to my webcam facing down, second camera GoPro in the bushes. So we'll have 2 angles of boxes facing the door. Ready to start.
That's quite a setup there, Todd.
Yeah, so that was good. And that was my selfie camera. I would have done more with my camera, but the normal camera on my phone has a broken lens. So that was my selfie of the setup. Let's see. So yeah, the original idea was, I mean, the 2 angles were just to kind of get a better idea of the boxes, get twice as many pictures in the same amount of time, you know, the same setup, and it worked out pretty good. GoPro is more of a wide angle. I think now you can reduce that with software. I don't know if I updated to the latest software to do that. Yeah, so you set up and you're going to capture, and I had to make a choice between capturing video, capturing pictures, or doing kind of like a time lapse. And I guess my preference is video because you don't lose anything. It's the best, but when I say it's cumbersome, I was going through my Raspberry Pi and using our beta data collector that Lila built, and I was running into some issues. I think it was with the data transfer. You know, videos can get big as well, and I wasn't able to capture, you know, video in the way I wanted. So kind of the moving around of video can get cumbersome, as well as once you parse it. You know, video is just, what is it, 60 frames per second, 30 frames per second. So it's a lot of images, and you don't really need images that close together when training. So after you capture and sampling, it could be you could be left with 1,000 images where only a tenth of them are different enough to really use. But it does give you more options. Pictures are easy. Oh, it looks like I spelled tedious wrong. Pictures are easy to capture exactly what you want. You can set up the frame, but to get the numbers that you're going for training a model, a couple hundred, it really can get tedious to push, capture picture, and set up the scene and capture picture, set up the scene. It can get really tough, but the good part about pictures is the control. And then time lapse is what I ended up doing kind of for both of them. Is it Goldilocks? Is it best of both worlds? Is it just right? I don't think so, but it does work. Everything here works. So for GoPro, I set it up to take a picture every half second, and for the webcam with Pi 4, after working with Lila, we set up the image capture app because I didn't have assistance, to take a picture every couple seconds, and the video wasn't saving correctly on the Pi. We set it up kind of like Timelapse to take a picture every 1 second until it got to 50 pictures. So each time I'd start the program, it'd take 50 pictures, I'd close it down and then start again. So what that ended up with is, let me show you. So I ended up there with 5 GoPro videos here. I was able to get one kind of shorter above video to save, but then I got a lot of images from above. Oops, I can kind of move them to mixed. So then these are all the images from above, and yeah, so that's kind of the data in its raw form. And so the reason I said that time lapse wasn't necessarily Goldilocks is because for the GoPro, it saved it as a video. So instead of, if I record for 5 minutes, instead of having a 5-minute video, I had like a 30-second video or something like that, with playing at 30 or 60 frames per second, and each one of those are taken half second apart. So I really had to figure out how to sample that to make sure that each one was different. I wasn't sampling it too tight together, or I wasn't leaving pictures on there. So I can show you. Let's see. I could show you this one to kind of demonstrate my process. This is a GoPro video. You see time lapse. So I just let it go, and I just throw boxes there and just kind of mix them all up. Kind of get different iterations of small boxes on top of each other. I did have one bag package, because you do order stuff, and I didn't want it to be just boxes, but we can talk about that later, whether that was the best idea. But so this is what the time lapse looked like, and this is what. Sorry if you can hear my son. He's not happy. And this is the one picture I was able to take from above. And as you can see here, this is in the dark, and this is kind of what I did. So this is the video where it's more real time, and I switched boxes and just tried to mix them up. And you can see it's getting dark, but if you want to inference at this, then you want to have examples of low light. So my next step, once I have these kind of raw data, was to clean it. First is sampling the videos and purging, and purging so that I have only ones that I want. And the way I've found to do this, of course, using ffmpeg, but I'll show you what I did because I thought it was pretty good. So I created a folder, for this data set. I had all these images in here, and then I created a new folder inside that was like video 1 images. And then from here, I do this in the terminal. And I'd run ffmpeg in here on the video that's in the folder above. And so that the results of parsing that video would be in this folder, and then I can look at them and decide. So like I said with the GoPro videos, the sampling rate was really important, and this is where you can kind of do a lot of testing, because you can do a lot of testing because I can sample this video. If you take a normal 60 frames per second, you can sample at 60 frames per second, and you'll end up with 1,000 videos. You can sample at 1 frame every 4 seconds and end up with 5 images. So you kind of do a little happy medium here. So I found, I think for the GoPro, maybe if I do say 20 per second. Then go into this folder, I could see I've got 91 items, and that's not bad. And then the way I look at them is get this view. This is how it is in a Mac. I don't know exactly how it is in Windows, but something where you can get a big preview and then just kind of sort through them and see if you see, this sample rate is pretty good. And what I'm looking for is how many images are like the same image. So here I'm clicking forward like 5 images at this, and it's just the same box. And it's like, okay, maybe I don't want 10, maybe I want to down sample that a little, but this is, pretty good. 91. If I do 91 images, plus or minus, the ones with me in them for each video, that will give me 500, for the 5 GoPro, that'll give me about 500 images. That's pretty good. So you can play with that sampling rate. And what I did to clean them was do this, and anytime where there's me in the picture like this, then I would just delete that picture and just do send to trash, send to trash, send to trash. So I just trash all the ones with me in them. If I've got a couple that are very similar, like these two are pretty similar, then I'd send one of those to trash using the shortcut command delete. And so then I'd end up with, maybe about 70 images per that, and then I'd combine them together and prep them for annotation. So it's kind of a little iteration of the of ffmpeg to get that right sampling rate. Any questions there?
Yeah, no questions so far, but if anyone does have questions, feel free to raise your hand at any point, and we can take a break to answer it.
Yeah, so let me show you if I just do 5. So then if I sample just 5 per second instead of 20, then I only have 24 images. And so this is better for the actual video. So that's what I do for the video of the images, because it's 30 or 60 frames per second. But for the GoPro, because it's already sampled as I'm taking it, I sample that more. Then I combine the images. So I mix them up, GoPro and that, into into this, and I ended up with 553 images. I've got some at dark, most of them are light, and I've taken out all the ones with people in it. Like I said, we can, now I'm debating whether that was even necessary. You know, as long as the boxes are clear and you can identify them as, you know, a human, if they're looking good, you could probably leave the person in the frame if you want, because that's not going to hurt the identification of the box. And about the package, I think when training the model, having the package, which is this white envelope there, be the same class as the boxes might have thrown off the model a little bit. But we could see, let's see. So I guess that's what I did, and then I built the model. I think I trained it for 200 epochs, and then this is me. You know, I'd like to do it live, but the setup is kind of tedious. So here's the model after 200 epochs, and unfortunately, our randomly generated boxes in this case are black, which doesn't show up too good against the matte, but you can see it kind of in action. So it kind of disappears there, but it gets the package pretty good as it's sitting. And this is kind of a visual test to see if there's any data I should add to help the model improve. And I can do that to go back and capture more data, or I could do that to you know, kind of, even maybe I have the data, but I excluded it. So you can see here in this that this area, the area at the top in the sun there, doesn't seem to like the package when it gets there. So what I would do is go back out and recollect data, making sure that I put packages up in that space where I am up there in, you know, in the sun, and then hopefully if someone comes and drops a package off there, it will pick it up. The other thing I was thinking about is, you know, if you're really serious about this, is taking notes on where your packages gets delivered. You know, a couple deliveries. You know, is the delivery person putting them on the mat? Are they putting them, you know, out on the stoop more, or at the base of the stairs? But kind of knowing where those packages are will help you collect data that you know, will help you recognize packages there. Okay, so that would be my next step, would be setting this up again. You know, probably different lights, probably some more testing at night. You could see in some of the images that the packages are really hard to see at nighttime. Some of them kind of disappear. So making sure that I've got that range, and then yeah, next step is writing the application to kind of to go along with this, to see what, in addition to just recognizing there's a package, what would the application do?
And so Todd, there's some suggestions here in the question or the Q&A section, where it's like, if you're trying to train for the nighttime, or if you're trying to like identify packages at night, you could use the IR camera or the Raspberry Pi Noir camera also. Any thoughts on that? Like, do you recommend that?
Yeah, I mean, I think having the right tools for, you know, your use case that you're doing is pretty important. I know we're working with a company that has that capabilities, and I'm not familiar with what it looks like in the daylight. So if it is, you know, like infrared, and I know I used one that kind of tinted everything in the day to be like a little pink, so that you can use the same camera for night and day. Then, I mean, the only consideration there would be to collect data with that and not try and, use these images that are normally hued and expect the model being used on a pink hued camera to perform as well as if you trained it on data captured with that camera. The other thing is if I guess just be sure to have data with that. If it switches to IR mode at night or something like that, make sure you have both data. But the model should be able to handle that as long as you have examples of both.
And AB actually has a question. I think he wants to share something. So AB, you can unmute yourself.
Yeah, thanks. Very nice. Exactly what the kind of.
AB, we're having some trouble hearing you. Can you speak louder or closer to the mic?
Can you hear me okay?
No.
It's a little low.
Can you hear me okay?
No, we can't. I mean, we can hear you, but it's a very, very low volume.
Maybe if I stop sharing.
Is it just me? Are you able to hear him, Todd?
I can hear him. It's just very low.
Okay, just give me a moment. I'll just check my volume. Okay. Yeah, can you hear me okay?
Yeah,
that's
much
good.
better.
Okay, yeah, exactly. A very good use case, exactly what I'm working on as well. So that is really good. Komal knows about it as well. So really, yeah, this is a very interesting problem and very fun to work as well. So yeah, so about the IR camera, right? So you covered it at later stage, right? There are some cameras which can change modes based on the duration of the day, at time of the day. So you have like a pair cameras, okay, and and it has a light sensor as well. So when the sun goes down, so the LEDs get triggered, IR LEDs get triggered, and you get that kind of a grayish pink, grayish shade, and you have to collect data for that. And in the daytime, if you use IR sensor, you get the pinkish shade. You are absolutely right. So that's the thing. So yeah.
That must have been what I've seen. But
Yes.
yeah, that two modes is sounds pretty good.
Yeah, most of the CCTV cameras, they have that kind of features. They have that, and yeah, I've used the no IR camera. It really works great if you want. So I try to create a spy car to just do it at night, and it really works really nice. You can see very clearly what's going on. So yeah, pretty cool. Nice.
Thanks, AB. And there's a question here from David, who asks, how long until the AI can tell what is inside the box?
Right. Yeah. What other kind of sensors can we incorporate? With some X-rays, some MRI. I don't know what would get in there, but right. Yeah, I know. I'm just waiting for one of you guys to post my address or something from one of these labels. Someone zoom in and say, hey, yeah, what's my resolution here? Stop zooming in on my address. Unless you want to send a gift, then that's fine. I'll track it. Yeah, so what do you guys have any ideas on? So Lila and I were talking a little yesterday on what we could do as an app. Okay, so you've detected the package, great. What should the application do? And I could share those, but I would like to hear what you guys think would be a good, whether it's an alert or how, any ideas there?
There's one that says prevent stealing.
Yeah, and that's what Como originally was suggesting, because especially, I mean, it's going to be harder in like an apartment complex, but that's especially where I think people would start to steal your packages, just like, or dorms or something. You'd have to set up a Pi camera in your hallway.
Yeah, and it's actually like a personal experience thing too, where it happened to me. I've had packages stolen right from like my doorstep. So that would be a really great use case, prevent stealing.
Definitely.
Any other ideas of what one could potentially do after you've trained the model to identify a package at the doorstep? How can you leverage that for an application? what would you want to do with that kind of information?
Yeah.
Count packages.
Oh, that's
That's
good.
also an option.
Yeah.
Oh yeah, we didn't think of counting when we were thinking of stealing, because I have seen videos of, you know, people
Take one.
like, I don't know, shaking them or trying to guess what's in them or something like that, and just taking one
Yeah.
out of three, or, you know, two of them or something like that.
That's a good point.
Right?
Yeah, another one is pretty funny, which is you could, and these are suggestions, not my ideas, but you could monitor your partner to see how much shopping he or she is doing.
Yeah,
they're
I guess
trying.
the tricky thing is, like, if you want your gift to be a surprise, this would be really good. You know, you've ordered a package and it's like, oh, good, I need to go pick that up before my partner sees it. On the other hand, it could also ruin a surprise. Like if the alert goes to like the wrong person or something, then you know that there's a package. But that's a good no surprises anymore. Yeah.
Right. Yeah. If someone's over shopping and hiding the boxes, you've already seen it on the doorstep.
And then there's a thing here that says always AI package detector launches. Stolen packages increased by 20%.
That's funny.
That's
funny.
want to be famous. Yeah. So what Lila and I were talking about, spoiler alert, should we say, we were talking about using the integration with Twilio to send a text message, you know, like right when the package is on your doorstep. That will help you, you know, get it faster. We're thinking of, you know, some other ways to combine it with other models to, you know, like, you know, maybe switch modes. Once it's detected a package, then start looking for people. And then, you know, hey, there's a package on my doorstep and someone comes, you know, what can you do?
Yeah.
With the scaring away, I just thought of, you know, if you set up some sort of alarm or toy, you know, do that when someone comes, and light, you know, starts, you know, integrating with the rest of your home security to be like, you know, hey,
Siren, that's a good one.
siren.
But maybe, yeah, you can, you know, some other, like there's a snapshot security camera app on GitHub. You can take photos when you see someone, record timestamps like a log file. I think the idea AB had of counting the packages in addition to that kind of state machine with package person, like, okay, there's been a package, there's a new person. Did the package number change? Is it more packages now, less packages now? Like, I don't know. So you can build a whole system, as complex or as not complex as you want. I mean, we even kind of discussed the model itself, like how, like, could we train a model to know different types of packages? You know, like FedEx versus UPS. I think that's getting a little into the weeds, but and then earlier in the Hacky Hour, somebody asked, can you do OCR? So if you did want to like get really high resolution pictures and find the label and do OCR on the label, that's a little weird, but you could say like, oh, I got a package from so-and-so or whatnot. But I think the main thing is with this software, you can integrate, you know, pretty much any Python library. So if there's a Python library out there or some other external API like Twilio or other hardware integrations, you know, like Raspberry Pi, you can do LED lights and whatnot. You really can get creative.
I actually, you know, speaking of creative, I want to highlight some of the interesting suggestions as well. There's one that says have a package retrieval system on the porch. When packages are detected, it will automatically bring them in, which is great. Like, you don't have
like
to worry about
kitty door or something.
Yeah, exactly.
Use your Roomba.
Roomba.
Another one is attach a speaker upon detecting a human approaching. Play audio snippet. Smile. You're on camera.
Yeah, that's good. Yeah, David T from Bolina. Thank you.
You could send your robot to collect the package. Also a good one.
Yes.
Yeah, that would be a sweet setup.
Yeah. So that's your challenge now. You have to make an app that will do something really cool, and we'll do an app too next week. It probably won't be as cool as, you know, sending a Roomba out to get a package. I don't have a Roomba, but we like the ideas. So those are some really good ones. Maybe we'll have to get a little more creative now, up our game.
Right. And I saw a mention of GDPR. I don't know if this is if it fits under it, but we do have like facial blurring where, you know, if you detect the face, you can blur it. But yeah, I don't know all the rules on that. And then if you're thinking of getting the face, then, you know, above probably not going to be the best evidence to take to the police of, you know, the top of someone's head, or, you know, their hair. It's been like, you know, catch this person who stole my package. I took a picture of the top of them.
Yeah. Or if it's
Yeah.
dark, or if they have a hoodie on or something, it'd be pretty impossible.
Right. So that's where like dual
Yeah, but that
cameras or
kind of
people.
defeats the purpose of trying to catch the thief, right? Like AB suggesting in the chat, like you can't. If
Yeah,
you blur the face, then you don't know who it
that's
is.
true.
Right. Or just blur it for public consumption.
Yeah.
Yeah,
Although that is the benefit of like this edge system, you know, even if you're not blurring the face, it's not getting sent automatically to a cloud. There's very low risk of like privacy breach or security breach, because you can just delete any images or whatnot.
all right. Oh, and I did want to mention, I forgot when I was doing my setup. I know you guys saw my masking tape job, but be very careful with your expensive cameras and laptops and stuff as you set them up on teetering locations. So yeah, this is not, we're not telling you to balance things on places where they can be dropped.
Yeah, disclaimer.
Disclaimer.
Okay,
Hi.
I think AB has another question or
Yeah, question. Yeah, I have a question. Sorry. So you might cover it next week, but I'm a little curious. I just want to ask, when you trained your model, how many classes did it have? Did it have only one class or package?
Yep, this one just had one class for package.
Okay.
Yeah, so the initial goal was kind of do a there not there, where that's why I kind of took pictures, and it was, if anything's on the doorstep, you know, it doesn't matter what it is, flag on that. But I think I trained it too much, or it was kind of a hack use of object detection, and I couldn't really get it to work. So I did end up doing, you know, classic object detection with drawing bounding boxes around all the objects. And that's where you know, I had that one bag, but it wasn't a good amount of pictures, that I just drew a box around and called it a package. And that's where, if I was going to do more of this, I'd probably split out, you know, I need more examples of them, but I'd probably split out, you know, package, or, you know, box, parcel, then maybe envelope if people are getting, you know, envelopes. But I'd probably try and split those out.
Okay. Another question is, can you show me that video again, which you showed the demo, how you ran it? I had a question on that as well.
Yeah, sure. I forgot I stopped sharing my screen. Desktop 2.
Yeah.
Can you see it?
Yeah. Just go forward. Yeah. When you're placing the packages. So yeah. I'll tell you to pause. Okay.
Sure.
At one stage. Yeah. Pause. So it detects you as a package as well. Did you see that? It draws a bounding box on your back.
Right.
So
yeah, that was it. Yep. Yeah, I saw that.
Yeah. So do you know the reason for that?
I don't. I can show you some other examples of some of what it did wrong as well that I'd like to train out. So
Yes.
you can see
This
with
one.
this,
Yeah.
you can see with this that it's you know, it's only 56. It's only 56%. You know,
sure.
where this is 99%. So
Yes.
so one way to address
Confidence.
that would be exactly
Confidence threshold.
right.
Okay.
So that's this. The thing that I am, well, I was confused about it because I thought all the images had that little trickle charger that I was using to power the Pi. In one of the videos I took, I used that to prop open the door as well as charge the Pi, and it marked that as a package. in every frame. And I thought I had it in every frame and never drew a bounding box, but then I looked at the images and it wasn't in there. But my thoughts on that were, you know, because I did so much in this area, it started to kind of overfit the background. And I think that's what
Because I'm having the same problem at the moment.
Right.
I'm having the same problem.
Was kind of like it's starting to get just anything that's not the background, which you know, it's not the worst thing for this use case, because you kind of want to know, is there anything on my doorstep? But you know, there are other use cases or other things where that may not be ideal.
That will be a false positive in other use case.
Exactly.
Okay.
And so that's why, you know, they're like the confidence level. There are things that you can do in the application code itself to kind of mitigate that, which we started to explore and which we can go into next week.
Okay.
And just so I didn't want to go too far into, you know, how I annotated this, because I talked a little bit about that last time, and there's a couple other hacky hours on annotation if you want to look at that. But it is when you know, the way I like to annotate is with video, so that I can use the interpolation. But with this, when they're all random, you need to annotate every box by itself, and I found a couple shortcuts just pushing and kind of sped that up. There's another trick, even though it's written there in CVAT. That's a good CVAT trick that kind of helped me go.
Oh, that's really helpful. Yeah, that's really helpful. Oh, thank you. Yeah, those were only my questions, and exactly, I think every user who will be trying to do this experiment will have that problem, and that's why I wanted to bring it up. And thanks for answering that.
Sure.
Thanks, Abby.
No worries.
Yeah, that'll be really interesting. I wonder, like, if people train it with different labels, or what classes people come up with. I'd be really interested, because we've done that before with other models we were trying to train, like that garbage collection one that is still a work in progress. If there's too many classes, it's a problem, but also if things are not similar enough, you know, it's very hard sometimes to define like practical labels, like in terms of like how you use something versus like how can the model detect that this thing is really distinct from this other thing. So like there's like two layers of labels, but when you're training the model, it's really like you have to think about what the model will look at it and how it will see it and what does that mean to it, not really how a human would understand like texture or how you use something like cereal box versus package or something. You know, like we know they're different. Does the model know they're different? How would you know if the model knows it's different? Yeah.
That's a really good point. And an example of that for this context is stacking boxes. You know, you saw when I was putting them there that sometimes I'd put them up on top of each other, and then when I'm annotating them, I didn't always annotate that there's three boxes on top of each other.
Like
it just there's a box.
Because it looks like a square.
Exactly.
Or like, and that's the point, like if your camera's up above versus your camera's like on the ground, like when does it look like a square? And so you need to have lots of like rotations, lots of like angles to make sure, or like just how your camera is set up. If your camera happens to be on the top, you have to just think about what will the package look like to the camera. If it's always going to be a person putting a package down, then you have to like think about the angles you're going to get it from that camera angle.
Right. So let me show you the result of that. So this is what I mentioned with packages stacked, where they're all stacked next to each other, but it just says package. The area up here is still getting missed, and then this down here is that charger thing where it thinks it's a package every frame. So I think it just, I wasn't going to ask the model to try and say there are three different packages here, especially some of the ones that I have.
And your assistants.
Right, and then there's my assistant. That's one when they finally helped. Yeah.
Yeah. So I mean, I really like that you did this example model because it deals a lot more with data collection and like the data collection process and all the considerations you have to think about that you mentioned at the beginning. Like all the other hacky hours we've done or the models we've done have been very about just like how do you use the tool, how do you train things, and that's really good. And people can look at those, like you said, you've already done annotation, but this is a really good hacky hour Todd's done for all the considerations you have to think about with data collection, because that really makes the model good or bad. And there's some documentation up on our docs that has data collection guidelines and like all the stuff that Todd mentioned, like weather, lighting, you know. But I think like the takeaway would be like, how are you going to use this model? You have to think about how it will be used, the camera, the items, people, no people, weather, and then just think about recreating that for your data collection process.
Think of it as kind of a living collection too, like you
Yeah.
said. So, we tested it and looks like that spot gets sun and maybe it doesn't, didn't have enough examples. So just after deploying it in the wild, you may need to add some more specific, like filling gaps of your data set, some specifically targeted data that you can get by, watching how it performs. So yeah, that's what, like Abby said, like a lot of your time when creating an app is just, can you build a data set to train a model to do what you want? And it's most of the time is going to be spent in data collection, cleaning, annotating, and hopefully then, the training is just going to be push button easy.
I'm not sure if you answered this question already, but did you do data augmentation for your data set?
I didn't do data augmentation for our initial one, which was, I had two classes, which was like nothing there and something there. I did augment the images that were empty with, kind of hue, saturation, that type of thing, grayscale, to just get a couple more examples, because otherwise it would just be 20 of the same picture. So I did do some data augmentation when trying to add classes to get that differentiation, but for the final object detection one like this, I didn't augment at all, because if I felt pretty good with the number, just for kind of proof of concept, but I could have, like I said, I did purge a lot of pictures either because they had me in it, or just, I was playing with the sample rate. Like I could have gotten a couple hundred more pictures just by sampling a little differently. And but I wanted to kind of train the model and then see how it performed, to do a little more targeted filling in of the gaps of how to add data.
Yeah.
But I think I haven't really tested it at nighttime. So.
Yeah, no, I was just gonna say, if someone doesn't know what data augmentation is, it's just manipulations of the images after you've collected them to make them brighter, darker, like Todd said, but you can also flip them, rotate them, crop them, so you can like zoom in. So if it's really hard to collect data, it's a way to make your data set bigger without having to actually physically go out and take another picture or video.
Nice hack. Okay, are there any other questions for Todd or Lila about data collection, training your model? Speak now or wait till next week.
Wait till next week now. And you can always find us on Discord.
Yeah, you can always find us on Discord. I can post a link shortly, but yeah, if there's no other questions, I just kind of want to make a quick announcement. Next week's Hacky Hour will be focused on the application of this specific model. But after that, on the 22nd, so that'll be a Tuesday, a little bit different from our typical Hacky Hours. On Tuesday, December 22nd, we're going to do a trivia Hacky Hour where we will ask questions like regarding all of the Always AI Hacky Hours we've hosted in the past. And the winner will just get a nice little surprise. I won't reveal that as yet. Maybe the next Hacky Hour.
Yeah, come back next Hacky Hour to find out what your prize is.
Yeah, join us. Yeah, so that's like a little tease for you, a little cliffhanger. And yeah, join us next week, next Thursday, 10:30 a.m., same time. And then after that, on the 22nd, that'll be our last Hacky Hour of the year. And we'll pick back up on the 7th in January. So with that said, thank you so much, Lila, and thank you so much, Todd, for
Yeah, thanks, Todd. Very
great
cool.
Good
demo.
times.
And great setup demo as well.
Yeah, that was fun. You set the bar high now for all the future data collection.
Yeah,
So yeah,
guaranteed no
thank you
demo mistake.
again. Grateful to have you all as part of the community, and we'll see you guys next week.
Yeah.
Take care.
Thanks. Bye.
Bye, guys.
Bye.